So hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So today we are going to represent the topic small sample test t-test in the course Discrete Mathematics with Probability and Test Hypothesis. So here we are going to calculate for the small sample. So let us see the problem based on the t-test. So before going to the problem, we are going to explain some of the basic concepts of the t-test. So problem number 1, if they ask what is t-test and what is the formula for the t-test, that we are going to explain here. So t-test is nothing but a statistical test that is used to determine whether there is a significant difference between the sample mean and the population mean. Normally we are going to apply the small sample only for the n less than 30, and it is developed by the Williams-Seilig-Ghost. The test is based on the t distribution. So t distribution formula is nothing but t equal to x minus mu by s by root n, where s is nothing but a sample standard deviation, n is nothing but a sample size, and whereas s by n is nothing but a standard error. So these are the basic concepts of the t-test, and if you want to remember, t-test means we are going to apply the t formula x minus mu by s by root n. Next is nothing but we are going to calculate the degrees of freedom. So degrees of freedom, after completing the t-test, we have to calculate the degrees of freedom. So degrees of freedom formula is n minus 1. If the sample value is n is equal to 27, means 27 minus 1, you will get 26. So this is calculated when the critical value at the given level of significance and the degree of freedom to decide whether it will accept or reject the null hypothesis. And we have to find the student's t distribution, that is using the bell shaped symmetrical mean is 0 based on the degree of freedom. The shape depends on the degree of the freedom, that is n minus 1. Smaller degree of freedom means more spread and heavier tail. Larger degree of freedom is closer to the normal distribution. Next we are going to approach the that is normal distribution in the approaches the standard deviation if the value increases n greater than 30. That is, independent sample can be calculated by t equal to x1 minus x2, that is sp, root of 1 by n1 plus 1 by n2, whereas sp is equal to root of n1 minus 1, n2 minus 1. So this is nothing but an sample test. Okay, we are going to calculate the sample test. So x1, x2 sample mean, s1, s2 is nothing but sample standard deviation, n1, n2 is sample size, sp is nothing but spooled standard deviation. If we want to calculate for the n1, n2 means, here the degree of freedom is n1 plus n2 minus 2. So next for the next we consider the equal assumed variance, we find out the next is nothing but independent sample size for the unequal intervals. So it is an unequal intervals means we have to find the xt equal to x1 minus x2 by root of s1 square by n1 plus s2 square by n2. Paired standard t-test is nothing but t equal to d by sd by root n, and d is nothing but mean of the difference x1 minus x2, standard deviation of the difference, n is nothing but the number of pairs, and df is nothing but n minus f. Next we can move on to the problem number 11, that is they ask how to find the degree of freedom for the unequal intervals. Okay, for the unequal intervals we can find s1 square by n1, s2 square by n2 the whole square by s1 square by n1 the whole square, s2 square by n2 the whole square by n1 minus n2 minus 1, where the sample size is nothing but s1 square, s2 square, sample size is n1, n2 is nothing but sample size. This formula provides the non-integer and as well as the unequal intervals. And if they ask the procedure for finding the significant difference between the population mean we have to apply the two-tail test, and as well as right-tail test and left-tail test are there. Two-tail test is nothing but h1 mu not equal to mu naught, whereas the right-tail test is nothing but mu greater than mu naught. Left-tail is h1 mu less than mu naught. So compute the test statistics t equal to x minus mu naught by s by root 10, where x is nothing but a sample size, mu naught is nothing but hypothesis population, and s is nothing but sample standard deviation, n is nothing but sample size. So here if you want to determine the degree of freedom means n minus 1. So usually we obtain the critical value of t from the table corresponding to the chosen and the degree of freedom. Decision rule is nothing but t calculated if less than or equal to t critical accepted h naught, and t calculated it is greater than critical value means we have to reject the null hypothesis. And finally we conclude that the words, that is whether this difference is statistically significant or not. So this is the concept behind the all the t-test etc. Okay, so these are the basic concepts. So we have seen the degrees of freedom. So totally the t-test is nothing but we t equal to x minus mu by s1 by root 10, and as well as for the two values also we are going to calculate, and degree of freedom also we have to recollect. So thank you for watching this video. Next we can see the f test and as well as the problems in the t-test.